Hello, students. Had a couple questions out of chapter 7, section 1. And we had a question on number 3A, 15, and then MC number 20. So let's take a look at 3A. So 3A says, got it. So it says 2,027 thousandths. So notice, look between A and B. There is a difference between these two, and it's this word right here. One of them has an and statement. So one of them means 2,000 as a whole number, then a decimal point, and then 27 thousandths. Without the and, you are now counting all of these additional numbers here as thousandths. So you have 2,027. Think of that just as a number, and then say now we're grouping those as thousandths. So if we're going to write that out, just like if I had 300, let's see here, let me just get white space. Who am I kidding? I'm never going to be able to fit it in that margin. All right, here we go. There we go. Oh, sorry about that. For some reason, I thought I'd be able to write small, and it's not going to work well. So let's do a similar problem. 300 54 thousandths. Okay. And then we'll repeat that with 354 thousandths. So in the second case, 300 and 54 thousandths. So tenths, hundredths, thousandths, and I have 54 of them. So my final answer for this one would be 300 decimal point 054. That's for the second one. For the first one, 354 of these things called thousands. I don't have any whole numbers. These are all thousands. There is no and statement, which gives me that decimal point. So that means I would write this as 354 thousandths. Now, if you want to, you could think of this as a fraction. Thousands have 3 decimal places. 354 has 3 decimal places. Oops, 354, and there we are. Outside of the horrendous scribble in the middle, 0.354. So there's the difference, and that's what they're trying to get you to see. The precision of your language is important. 2,027 thousandths, that's like having $2,000 and then a little tiny bit. The next one is 2,027 of these very, very tiny pieces. So, I mean, maybe you've got a couple dollars at the end of the day, but nowhere near the same thing. Okay. So that's the idea for 3A. Let's see here. And then 15. Okay, so 15, argue that there are infinitely many terminating decimals between any two specific terminating decimals. Well, again, this is kind of up to you to give an argument, your argument as to why you believe that is true. And hopefully you do believe it's true. So let's see here. How many terminating decimals are there? Now, again, they give you two numbers over here. Whoops, switch to the white pen over here. They give you two numbers. Let's just say that we had between 0.3 and 0.4. Now, this, of course, is further apart, but how many terminating decimals are between these two numbers? Well, let's just see. Of course, we could have thought of this with an additional 0, because initially it doesn't look like there are any, and then you could say, aha, 0.31, 0.32, 0.33, 0.34, and you're like, okay, so I've got a chunk of numbers that'll work just fine. All of them have 2 digits, and they are definitely terminating. And you can say, okay, well, that must be it. Well, what if somebody else says, but wait, couldn't you rewrite this number with another zero? Well, yeah, then you could have 0.301, 0.302, 0.303, 0.304, 0.305, all the way up to 0.399 in terms of having 3 decimal places. Okay. So again, now we're looking at around 1,000 of them, right? But you could say, okay, that's great. So I've got 100 something, I got 1,000 something, but couldn't I then put another zero at the end, right? Well, how many terminating decimals are there between these two numbers? Well, now you could say 3001, 3002, 3003, all the way up until you get to around 0.3999. So again, we're looking at around 1,000 now. So we started with around 10, right? Then 100, then 1,000. And if you notice, I'm not changing the values. All I'm doing is what they call adjoining or putting a zero at the end that really does not change the value of the number. So how would I show that there are infinitely many? Not 100, not 1,000. Think about it though. How many zeros could you put on the end? Interesting idea, right? Maybe more than what we were talking about. Let's jump over to the MCs and take care of the next question. MC question 20. Got it. Alan, gosh, Alan is so believable. That Alan. So let's take a look. So first off, a couple things to think about is definitely on the right track. I like Alan's thinking. 4 is less than 5, which means that 1/4 is going to be greater than 1/5. Remember, if the numerators are the same, the smaller denominator is the larger fraction. Okay, so this is true. Alan, you're looking good so far. Alan then concludes, aha, so that means 0.4 is greater than 0.5. And you got to say, whoa, 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 whoa there, Alan. Notice up here, if we were to take this inequality that we know is true and then multiply on both sides by a positive number, then the sign is not going to change. And 1/10 times 0.4, or 1/10 times 4 would be 0.4. 1/10 times 5 would be 0.5. And we can see, no, that does not make any sense. Okay. We could also go back to the definition. 0.4 is 4/10. 0.5 is 5/10. When they have the same denominators, you simply compare the numerators. And we know that 5 is greater than 4, so 0.4 would be less than 0.5. Okay. Now, to me, I'm not 100% sure what Alan's doing, other than maybe looking up here and saying, aha, 1/4, that must be 4/10. Or maybe even thinking that 1/4 would be 0.4, perhaps, and 1/5 would be 0.5. Um, that's that's going to be an issue, right? So we want to check and see what is going on with your understanding, Alan, about 1/4 and the decimal number that is created from that one. But again, I'm not 100% sure what Alan is truly doing, other than made a few correct statements and then at the end concludes, aha, so if the reciprocals, which is kind of like the fraction form of these numbers, comes into play, and I think maybe there's a thought of, so there must be some kind of fraction, like a reciprocal type of relationship that 4 becomes a 0.4. But we aren't doing the same thing. The reciprocals are actually very different. Reciprocals are multiplicative inverses. And multiplying by 1/10, like we did in this problem, is not the same thing as the multiplicative inverse. So it's not actually changing the values in the same way. And that's why this is incorrect, and we can kind of show why. That's it. All right. So that's what we've got. We got the 3 questions there. Hopefully that's helpful. Let me know if you have other questions. Off you go.